Okay. I want to pick back up in lesson 8.2 where we left off yesterday. And we were still on that first page, working with our ellipses that are centered at 0, 0. We had just completed example 1, where they gave us an equation, and our goal was to find vertices and foci. Now we're going to do just the opposite. They're going to give us the information, and our job is to write the equation and also sketch the equation. So let's look at it. Example 2. Find the equation. So notice they want us to write an equation of the ellipse with foci 0, -3 and 0, 3, whose minor axis has length 4, and sketch the ellipse. So two things going on here. We have to write an equation. We have to sketch the ellipse. Debating how I do this. How about I let you guys take the lead? Based on what they provide us, using what we know about ellipses, using our chart up top, any thoughts, information you can share with me? What do you see, Ethan?
Well, it looks like that because the foci is 0 and then numbers, that it might be the second.
Yeah.
Like up there,
Okay.
the second column down.
So in class, it's being suggested to me that this ellipse is from the second column up above, and that is as we are looking at the foci. And I agree that this is going to be a right column problem because my foci are 0, -3 and 0, 3. If you go up to the chart up here, my foci, depending on which column I look at, are either plus or minus c, 0, or 0, plus or minus c. Because they're 0, I know that this is centered at 0, 0. So I know this is, not moved. Ours, if you can't see, I've gone too far there. Ours are 0, number. Over here on the right, it's 0, plus or minus c. So yes, that tells us several pieces of information. This is in the form 0, plus or minus c, which means it also tells us our c value. What is c? C is 3. And before I forget, I'm going to write down that this is a right column problem. And again, it's a right column problem because of the fact it's 0 and then the number. I'm also going to go ahead and write the equation down because my job later is to write the equation, yes? So the basic, if it's the right column, we're going to be doing y squared over a squared plus x squared over b squared equals 1. Okay, so far so good. We know our c value. We know it's a right column because of how those foci are set up. What else can you come up with for me? Okay, they tell us minor axis is length 4. What does your chart say about the minor axis? 2b. So if the minor axis has length 4 and the minor axis is 2b, then that means 2b equals 4. And if 2b equals 4, b is 2. Okay. Do we have all of our information to write our equation?
Is A also 3?
No.
Okay, I didn't know if it would be because of the vertices in the meter. So it's got the plus A, the plus or minus, the plus or minus. It's C. So it makes no sense.
C and A are not the same number. Vertices and foci, if you look in your picture, are at 2 different points. Vertices are at the end of the major axis. Foci are a little bit set in from them. So yeah, so to write our equation, we have to know A and B. We have B. We have B and C. I need B and A. How do I get A?
A relationship?
Pythagorean relationship? The Pythagorean thing, okay? As long as you can come up with Pythagorean thing, you're good. So, okay, Pythagorean thing. What is the Pythagorean relationship on an ellipse? C squared equals A squared minus B squared. That is also up in our chart, right? And keep reminding you, it's all the information's in the chart. I'm not doing magic here. So let's do some math. 3 squared equals A squared minus 2 squared. 9 equals A squared minus 4. Add 4 over, and A squared is equal to 13. And if A squared is 13, how do I find A? Square root. And so I'm going to say A is the square root of 13. Now, for the benefit of when we write the equation, I'm good with A being the square root of 13. For the benefit of when we graph this, I need a number approximation here. What is the square root of 13 approximately? Because we're going to need that information when we go to graph.
4 and 5. Or, 3 and 4.
More specific than between 3 and 4.
More towards, like, more towards 4.
Okay, more towards 4. And that would get you there graphing-ish. Okay, 3.6 something. Okay. And again, for writing the equation, I'm going to use square root of 13. However, when we go to graph this, I don't know how to count square root of 13. I know how to count 3.6. Or Jake was saying between 3 and 4, closer to 4. You know, that might get you, that would get the idea across on a graph, depending on how specific your graph is. Okay. Ready to write an equation? Okay. Y squared over A squared. What's A? Square root of 13 squared. Plus X squared over B squared. So X squared over 2 squared equals 1. I am going to clean that up a little bit and do my squares. What is the square root of 13 squared? 13. So y squared over 13 plus x squared over 4 equals 1. And there is the equation I would be looking for. Our next job is to sketch it. I don't know how you set your paper up. I was kind of setting my paper up to sketch it in the middle of the page. You're going to have to find a place somewhere. Okay, I am working on, I just put an XY axis there in the middle. Huh? I got no answer for that one. I will just fix it and try and make you believe it was a figment of your imagination. See? XY axis. I don't know what you guys are talking about. Okay. Don't ask. It's been a day. That's all I have to say. It's been a day. Okay. XY axis. Okay, what kind of things can we graph here? We were provided the foci, right? Which, by the way, I'm going to mark each direction on my x and y axis for each way. Okay, so if you can mark 4 each way, or, well, you don't even have to go 4 all ways, but let's see, the first thing we were provided in this problem were the foci, 0, -3, and 0, 3. Where are 0, -3, and 0, 3? Which way? Yeah, up 3 and down 3. For reference, I went up 3, I went down 3. Those are also my C values. Okay, when I go up 3 and down 3, those are my C values. And your C values will always be your foci. So if you want to, whoops, I don't know, it's going to get kind of jumbled in here, but if you want to label that as a foci, you can. Or put an F for foci. Okay, what else? What? We have B. I'm going to hold off on B for a moment. Okay, and I'm going to hold off on the minor axis and the B for a moment. We just did our foci. What is out past the foci, according to our picture? The vertices, right? Out past the foci are the vertices. What are my vertices? It's my A values, right? It's 0, plus or minus A, which is plus or minus the square root of 13. And this is where I said I can't really count square root of 13 on a graph. And so that's where I wanted the approximation of 3.6. So my A values, vertices, according to the chart, 0 plus or minus A. So I'm going to go up 3.6. And I'm going to go down 3.6. That's using my A value there. And if you want, those are my vertices, right? Okay, remember your vertices are at the ends of your major axis. That is as far as the major axis goes, those are the final endpoints. Foci are inside your vertices. So, A value, and let me for a moment, I hate to move this too much, but let me for a moment go and point at our chart up here. If I look at my chart, okay, our C value told us to go up and down to get to our foci. Our A values told us to go up and down to get to our vertices, right? So A values are the long length of the ellipse. How do we figure out how far my ellipse goes the other way? Use your B's. Okay, so A's are your major axis, B's are your minor axis, which is why B is always smaller. What is my B value? My B value is 2. So I have vertices and foci going the long way. And then the other way, I'm going to go 2. And those are my B values. So I'm going to left and to right. What do I use to draw the ellipse? Your A values and your B values. So your A's are your vertices, and then B's are just, unfortunately the B's don't have a name. They're just the endpoints of the minor axis. I don't have a better name for them than that though. Now I'm going to attempt to draw this ellipse. I do better drawing an ellipse if I don't have to connect the dots along the way. Doable. We'll take it. So my ellipse looks something like that. Questions there? the idea of how to sketch it? And we'll sketch at least one more today, don't worry. But now, and again, keep in mind that one was centered at 0, 0. Because it was centered at 0, 0, it made life a little bit easier, obviously. And I knew it was centered at 0, 0 when I had that 0, -3 and 0, 3 as my foci. Okay. I left it up there long enough. We're ready to turn the page. What happens when I turn the page? Our formulas change because instead of just talking about ellipses centered at 0, 0, I'm now talking about ellipses centered at HK. Okay, so now with a parabola, our vertex was HK, right? Well, my vertex is not HK because I still have vertices at each end of the major axis, but that center point, okay, that center inside the ellipse is HK. So now I heard the equations change. However, the only change with the equations, instead of x squared and y squared, x minus h squared and y minus k squared. So as always, the h is the x coordinate, so it goes with the x, and the k is the y coordinate, so it goes with the y. That didn't change. So that's the change with the standard form. My focal axis changes how it's listed. On the front side, it was listed as x-axis because the longer axis is the x-axis. Well, if you take this and you move it the center off 0, 0, it's no longer the x-axis. And so they just say y equals k. Over here, it was the y-axis. Again, you take that and move it, it's no longer on the y-axis, so they use the line x equals h. Now, can you see how the foci and vertices connect? The problem we just did on the front side, my foci were 0 plus or minus c. Do you still see kind of a 0 and a plus or minus c? And then just an hk added in. So it was on the front side, my h and k were both 0, so 0 plus or minus c. Now h and k are going to be some number other than 0. So over here, it's still plus or minus c and a over on the y value. Over here, it's still plus or minus c and a in the x value, just like the front side, except tag in the h and k. Major axis, minor axis, and Pythagorean relationship do not change. They're still the same. Okay? And as I reminded and talked about you guys yesterday, all this information is provided on the test, right? So it's not that you have to memorize it. It's not about memorizing, it's about understanding how to use it. Okay? One other thing listed right here, I'll be honest, we probably, if it's like my morning class, we won't have time to talk about it, but eccentricity of an ellipse. Okay? Eccentricity, eccentricity, I don't know. Not electricity. No, there's no L in there. Okay. Eccentricity of an ellipse, there's a very basic formula, and I would just use E equals C over A. When it gets fancy there and it says E equals C over A, which equals square root of A squared minus B squared over A, that's just a way to find C. Honestly, you guys know how to find C if you need to, because you know the Pythagorean relationship. So easiest to me is the eccentricity is C over A. Now, what is eccentricity? And it talks about how long or how elongated the ellipse is. Eccentricity is always going to be between 0 and 1 on an ellipse. And it's how elongated the ellipse is. The larger the E value, the more elongated the ellipse is. Okay, so I think the more stretched and skinny, does that make sense? I don't know how exactly you want, to think about it, but that's what we're talking about with eccentricity. Okay. Shall we delve into example 3 here? Again, you've got that chart in front of you, right? This is one of those chapters you should always have your notes beside you when you're doing their homework. Nothing else for the charts. Okay. Find the standard form of the equation for the ellipse whose major axis has endpoints -2, -1, and 8, -1, and whose minor axis has length 8. That's what you're provided. They only ask us to find the equation. I'll be honest, I'm going to sketch a picture along the way because some of you might find that helpful when we're finding certain information. I'm not going to say you'd have to sketch a picture though. Okay. Thoughts? What can you tell me about this example? Okay. It tells us minor axis has length 8. Yes? If the minor axis has length 8, what do we know according to the chart? I agree with what you both said. Okay. Minor axis equals 8. Well, according to the chart, minor axis is 2b. So we know 2b equals 8. And then using our math skills, we know b is 4. Are we good there? Okay. What else? Use that chart to see what you can come up with.
Yeah, I'm trying to figure out, it says major axis endpoints, but it says 2A in the thing, so I'm trying to figure out this thing.
Okay, so the length of the major axis is equal to 2a. They're giving us the major axis endpoints. What? Okay, so that's what I was just going to suggest. I was just going to suggest flip back to the picture on the front. What is the name of the major axis endpoints? And the major axis endpoints are the vertices, right? If you look, major axis is a longer axis. What's at the end of the longer axis is the vertices. So they didn't come out and tell you, here's your vertices, but that's what they gave you, your vertices. It'd be so nice if they just would have said, oh, vertices are, but no. Major axis endpoints. So these are vertices is what they're giving you. And that's, again, putting it all together, understanding what are the major axis endpoints or the vertices. Okay? What else can we figure out there then? And talking about major axis endpoints. Our A value? We can. How do you want to figure out that A value? Or you're not there yet? I don't feel like we explicitly have H and K. We have one of them.
Oh, well, we have the K.
Okay. So, and this is an important, as we move forward here. Sadie says we have the K. How do I have the K? They both have -1 in the Y value, which also tells me, is this left or right column?
Left, because the both second curves are the same.
Okay. The light's starting to turn on in here. Hopefully virtual, you guys are starting to see it too. So it's getting brighter, okay. -2, -1, 8, -1. As I go up here and look at vertices. So look at your formula for vertices. Over here, it's H plus A, plus or minus A, comma K. So that's saying that both vertices, they would have different X values, but the same Y value. Over here, it's H, comma, K plus or minus A. So this is saying the vertices would have the same X value, but different Y values. What do we know about our vertices? they have the same y values. Okay, so right there, by looking at all of that, we just found, first of all, we now know that this is a left column. Okay, and it was pointed out then that these are K. Now, before I forget, you guys said left column, yes? I'm going to write my equation down. Not like the filled in, but the generic form. So I'm going to write x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay, we're making progress here. We have K now. We already had B. We still need A and we still need H. Now, at this point, I'm going to sketch a picture. However, once you start seeing this, you don't have to have a picture right now. You can finish this problem without a picture. Okay, so I'm saying that. It all depends on how your brain puts this all together. Does that make sense? Some of you will want the picture. I don't know, maybe by the end no one's going to want the picture, but at this point the picture is my teaching tool. So, over to the left, I am sketching a graph. I did try and move my x-axis up a little bit because I know my points they give me are down a little bit. And I'm going to go ahead and put the dots on here that we know, which are my vertices of -2, -1 is one of my vertices. And my other vertice is 8, -1. Okay. Thoughts? I need A and I need H. Seeing anything?
I came up with something that's probably not right.
Give it a shot.
Well, we have K, so can't we use the foci formula and put in K and use the H's from that to get your C? Each of your C's.
But I don't know my foci right now. I can't do anything with foci and C because I don't know either the foci or my C value. Nope, I actually don't even find C on this particular problem. Okay, my vertices are the end of what? The major axis, yes? What's in the middle of the major axis? The center. Can we use our math skills, just math logic here, to find the center of this ellipse? What's the center of my ellipse? What'd you say?
5.
Okay, so what's 5?
It's in the middle of 8, -2, -1, 8, -1. So it'd be 5, -1.
Wait, not 5, -1.
Negative.
I thought you had something. There's a 5 that's important here, but
What is it? Or 3, -1. Yeah, it would be 3, -1 because it was 5 over.
That's, yeah. Okay. What is the distance from negative 2 to 8? From negative 2 to positive 8 is a distance of 10. What's half of the distance of 10? 5. So if you count in 5 either way, you're going to meet in the middle, and that middle is your center. So if I count in 5 from 8 and 5 from negative 2, that puts me at 3. I know I'm at negative 1 because that's where the others are, right? So my center ends up being 3, negative 1. Which means I now have H and K.
These are standard equations then? For 5A or
No?
What do you have?
We've already mentioned A.
O?
Five.
A is 5.
I'm so lost.
Okay. No loss.
Well,
Nope.
that makes sense. That would be A.
Okay. Major axis. How long is my major axis?
2A.
It's 2A according to the formula. And what's the actual length of the major axis? 10. From vertice to vertice, remember, is the major axis because these are major axis endpoints. I'm trying to make all the connections for you. I know it takes time. Okay, so what I'm trying to say here, the major axis endpoints were 10 apart from each other. From vertex to vertex is a distance of 10. So major axis is 2A. If 2A equals 10, then our brilliant math skills say A equals 5. So when Jake earlier said 5 right off the bat, and then I got confused, we got confused for a moment, we got there again. The 5 is how much you had to count in, right? Or, once you know the center, to get to your vertices, you count 5 out. Because remember, it's HK, and it's plus or minus 5. Okay? If I'm going to finish graphing this real quick, I use my A values to go out on my major axis. What do I use to go out on my minor axis? The B's, because the foci are C. Okay, so how do I finish drawing this ellipse, just for reference purpose?
4.
Yeah. B is 4, so I'm going to go up 4 and down 4. And those are my B values. Okay? And that's up 4 and down 4 from your center. Not from 0, 0. That's what you guys did, isn't it?
Yeah.
From the center. Now, I struggle with drawing this ellipse because of it's off center.
Mine really was going to be with a 0.
Yeah, not horrible, but we'll go with it. Mine never look like very good ellipses when I'm trying to connect the dots. It doesn't happen. Okay, just realized I'm almost out of time. I don't want the bell to ring on us. Other thing I didn't write down is that we did find the center of 3, negative 1, which means those are my H and K, correct? I just need to write my equation and I'm done. Excuse me. X minus H. So X minus 3, quantity squared over A squared, 5 squared, plus Y minus K, Y minus negative 1. So Y plus 1 squared over B squared over 4 squared equals 1. Officially, I tend to square my A and B values when I write my final answer. So x minus 3 squared over 25 plus y plus 1 squared over 16 equals 1.
I can see that now, and I guarantee later on.
Yeah, I'm gonna do it. I'm gonna be sitting there. Yeah.
Okay, so unfortunately, I had hoped to at least get through the next example too, but it's just not in the cards today. This is where I got in morning class too. So my plan for tomorrow is, yes, I'm going to go through example 4 because I feel it's necessary. On the back side, you will see, or on the next page, there's example 5 and there's an A, B, C. I'm just going to do one of those, probably just example 5A. And then from there, I would encourage you guys to at least start the homework a little bit tonight, and then maybe we can talk questions as time allows. Or maybe those 2 examples will take the whole period. I don't know. But I'm definitely, we'll talk questions if we can. If you are virtual and you need the homework, there you go. It's in Skyward, but it's page 599, 2 through 6 evens, 7 through 10 all, 22 through 40 evens, 46, and 48. Not due tomorrow. It will be due Monday, right? Yes.
Not tomorrow, I guess Monday, then, yeah.
That's me processing what day of the week is it.
Yeah.
Let me know if you guys have any questions.